Hi students, today our topic is differentiability. Let us come to the graph straight away. Here, let us consider a curve f of x, and here we have a secant over there, that is AB. Okay, now what is the slope of secant AB? Slope of secant AB equal to what? Now what is slope? y2 minus y1 by x2 minus x1, which means, so here it is y2 y1 and x2 x1, which means that y2 f of a plus h minus y1 is what? F of a, so f of a divided by x2 minus x1, a plus h minus a is what? H. So slope of the secant AB, f of a plus h minus f of a by h, which means that change in y coordinates with respect to change in x coordinates, which is also known as average rate of change in y with respect to x, also known as average rate of change in y with respect to x, straight away, which is also known as delta y by delta x, which is nothing but average rate of change in y with respect to x. Okay, now if b value approaches to a, what happens? Clearly secant will be like this, moves like this. So clearly it is very closer to a, b approaches to a. Now secant will convert into tangent, which means that if b approaches to a, then what happens? Secant AB is approaches to tangent at a. Okay, means the tangent at a. Secant AB approaches to tangent at a, which means that average rate of change of AB approaches to instantaneous rate of change. So which means delta y by delta x. What is delta y by delta x? Clearly it is f of a plus h minus f of a by h. I write it as delta y by delta x. Why? Because rate of change in y coordinates with respect to x approaches to, so dy by dx at x equal to a, which is also known as derivative of the given function at x equal to a. See, clearly as b approaches to a, what happens? Delta y by delta x approaches to dy by dx at the rate x equal to a. Now see, what is the difference between these two, delta y by delta x and dy by dx? It is the average rate of change and it is the instantaneous rate of change. What is the difference between these average rate of change and instantaneous rate of change is what? That is just h value approaches to 0, which means that, why? Because here as b moves very closer to a, the distance between these two is very lesser, which means that almost approaches to 0. Clearly this is what? H. So that the distance is very lesser, which is also approaches to 0. So that it can be written as limit h tends to 0 delta y by delta x is equal to dy by dx at x equal to a. Here h is what? Difference between the x coordinate, which is also known as delta x. It can also known as delta x. Okay. Clearly from this figure, what we observe, as b approaches to a, so the limiting position of average rate of the secant, so average rate of change is equal to the instantaneous rate of change. As b value approaches to a, average rate of change is equal to instantaneous rate of change, which is also known as the derivative. Now coming to the right hand derivative, which means that slope of the tangent from the right side of a, which is known as right hand derivative, which means what? Right hand derivative, which means as b value approaches to a, which means that h is very closer to 0. As b value approaches to a, h is very closer to 0. Nothing but limit h tends to 0 secant of ab, which is nothing but f of a plus h minus f of a whole divided by h. Right? Then coming to the left hand derivative. Now let us consider a point that is c. Here also ac is a secant. Okay. Now as c value approaches to a, similar way, as b value approaches to a, the secant is equal to the tangent. Limiting position of the secant is equal to the tangent. That's why as c value approaches to a, the limiting position of this secant is equal to the tangent. Now this is nothing but the left tangent, which is also known as left hand derivative. Slope of the left tangent is what? Left hand derivative. Now coming to the left hand derivative, so here also this is what? H. So clearly these two are same, and as c value moves very closer to a, which means that this secant transform into the tangent at a. Now see, as c approaches to a, what happens? H value approaches to 0. Here also clearly limit h tends to 0. Now what is the slope of the secant here? y2 minus y1 by x2 minus x1, or y1 minus y2 by x1 minus x2, which is also known as f of a minus h minus f of a whole divided by, what is the difference between x coordinate? That is h. So these are the right hand and left hand derivatives. If right hand derivative is equal to the left hand derivative, then the limits are exist, then the existing limit is nothing but the derivative at x equal to a, which is also known as f dash of a. Clearly if right hand derivative is equal to left hand derivative, so this curve has a unique tangent at x equal to a. If right hand derivative is equal to the left hand derivative, this curve has a unique tangent, which means the only one tangent at x equal to a. If it has a unique tangent, it is differentiable at x equal to a. So that clearly it is known as the function has unique tangent. At x equal to a. Okay. Now coming to the right hand derivative. So if a plus h is equal to x, for suppose, now h is what? X minus a. as h value approaches to 0 from the right side, which is positive, h tends to 0. Now x tends to a plus. Clearly, now this can be read as limit x tends to a plus f of x minus f of a by x minus a. This is also the right hand derivative. Now coming to the left hand derivative, which is limit h tends to 0 f of a minus h minus f of a by minus h. Now here, if a minus h equal to x, clearly minus h equal to x minus a, and here as h value approaches to 0, which means that x tends to a from the left side. Why? Because it is in the left side, left hand derivative. Now clearly limit in place of h tends to 0, what we need to take? X tends to a minus f of a minus h is what? X minus f of a by minus h is what? X minus a. Clearly, so what is the right hand derivative? Limit x tends to a plus f of x minus f of a by x minus a. So what is the left hand derivative? Limit x tends to a minus f of x minus f of a by x minus a. So coming to the definition of differentiability, if right hand derivative is equal to the left hand derivative, then only differentiation exists, which means that here left limit of this given value of this value is equal to the right limit, so that limit x tends to a plus f of x minus f of a by x minus a is equal to limit x tends to a minus f of x minus f of a by x minus a. Clearly from this what we get? So limit exists finitely, and the existing limit is what? Limit x tends to a from the right side and from the left side, which means that x tends to a f of x minus f of a by x minus a, which is also known as the derivative at x equal to a. So if f of x is from this, if f of x is differentiable at x equal to a, then clearly limit x tends to a f of x minus f of a by x minus a exists finitely. If it exists finitely, the existing limit is called derivative at x equal to a. Here we have some important topics which have to be noted. The first one is, if f of x is differentiable, then f of x is continuous. If f of x is differentiable at x equal to a, which means that f of x is continuous at x equal to a. Conversely, may be possible, may not be. Why? Because conversely not necessary. Why? Because what does mean by conversely? If f of x is continuous at x equal to a, then f of x may be differentiable, may not. Why? Because let us come to the graph. For suppose if I take like this, yes, yeah. So here this is the sharp corner. So this is the very important concept, sharp corner, for suppose at x equal to a. Now check the differentiability at x equal to a for this function. At x equal to a we have a sharp corner, right? Now coming to the left derivative, so left derivative for this function will be like this, and right derivative for this function will be like this. So both are not same. Clearly here the left hand derivative is not equal to right hand derivative. Of course the function is continuous at x equal to a, but it is not differentiable at x equal to a. So clearly, so we have one more, that is coming to the modulus function mod x. If I take mod x, what is the graph of mod x? It should be like this. Okay. Now clearly at x equal to 0, it is not differentiable. Why? Because clearly mod x is continuous at everywhere, but at x equal to 0 it is not differentiable. Why? Because, so coming to the graph of mod x, so here what is the left derivative? It should be like this, which is a positive slope, which has a positive slope, and coming to the right hand derivative which has a negative slope. So here left hand derivative is positive and right hand derivative is negative. Clearly, so this is the left hand derivative for mod x. So this is the left hand derivative and this is the right hand derivative. Now clearly, so left hand derivative is negative. Why? Because it is in the second quadrant, and right hand derivative is positive. Clearly left hand derivative is not equal to right hand derivative for the modulus function. Why? Because it has a sharp corner. So you please carefully with the sharp corner. Why? Because at the sharp corners the function is continuous, but it is not differentiable. Please remember that. Function is continuous, but it is not differentiable. So this is a very important point to note. Okay students, thank you. In the next video we will discuss about some problems on continuity, sharp corners, and the problems on differentiability. Okay students, thank you, bye.